In this video, we're going to look at the first step in developing oxidation and reduction half reactions. So that is simply splitting up the skeleton reaction you're given and then determining if a reaction should be oxidation or reduction by examining the oxidation numbers. We're going to start with a simple redox reaction. So here we just have two metals, magnesium and copper, reacting. So to break this into our half reactions, I'm going to just highlight like species. So we have magnesium. It will be paired with magnesium in one half reaction, and copper will be paired with copper in the other half reaction. So our magnesium half reaction will start by just writing magnesium solid to magnesium 2+. You may be able to balance this now, but we'll look at balancing half reactions in a lot of detail in the coming days in the course. For our copper half reaction, we're going to start with copper 2+ and then form copper solid. So even without adding electrons, we can determine if these are oxidation or reduction half reactions by examining the oxidation numbers. So magnesium is in its elemental form in the reactants here, and it's in the 2+ form here. So it goes from an oxidation state of 0 to an oxidation state of +2. Because its oxidation state is increasing, this is an oxidation half reaction. So magnesium is undergoing oxidation. Copper 2+ is reduced to copper 0 or elemental copper. So because its oxidation state is decreasing, copper is undergoing a reduction half reaction. Our next example is a little trickier. So here we have chlorine gas forming chloride and chlorate. In this example, the same species is actually being both oxidized and reduced. And we'll look at which product is the result of oxidation and which is the result of reduction. So I'm going to start by just highlighting chlorine kind of halfway. And then one half reaction will be the production of chloride. And then I'll highlight chlorine the other half. And that half reaction will be the production of chlorate. So our first half reaction is going to be chlorine, Cl2, to chloride, Cl-. This half reaction, we have elemental chlorine, so it has an oxidation state of 0. And then we have chloride. It has an oxidation state of -1. So our oxidation state is decreasing, and we have a reduction half reaction. In our second half reaction, we'll have chlorine gas again, but this time producing chlorate. Don't worry about the oxygen that's there. We're going to learn how to balance complex half reactions involving oxygen and hydrogens. For now, we're just going to look at the oxidation state of chlorine. So chlorine has an oxidation state of 0 in the reactants. It's elemental chlorine. And in chlorate, it has an oxidation state of +5. And so we're going from 0 to +5. So this is going to be our oxidation half reaction. In a reaction where the same species undergoes both oxidation and reduction, this is called disproportionation. So that's just a fancy word for saying that Cl2 is both oxidized and reduced. Our last example is going to be our most complex. So in this example, we have two manganese species, MnO4+ and Mn2+, and we have two chromium species, Cr3+ and Cr2O7. So we're not going to worry about those oxygens at all when we're looking at our half reactions. We're going to look at the other elements, specifically manganese and chromium. So manganese starts as permanganate, MnO4-, and manganese 2+ is produced. In permanganate, manganese has an oxidation state of +7. Oxygen is -2 each, so manganese is +7. Manganese 2+ is +2. So here we are going from +7 to +2. This is a reduction half reaction. In our chromium half reaction, we start with chromium 3+, and we produce dichromate, Cr2O7 2-. In this half reaction, we're starting with an oxidation state of 3+, and the oxidation state of chromium and dichromate is +6. So that's -14 total from the oxygen and +12 from the chromium, and since there's two +6 each. So we're going from +3 to +6. This would be an oxidation half reaction. We're going to learn how to balance the oxygens and the hydrogens when we talk about balancing an acid and a base.